Did you know that the author of The Boys, the comics, literally visited Liverpool like yesterday? Because I didn't. Well, I mean, I didn't know until after the fact. I mean, I just walked into Forbidden Planet, which is in Liverpool, just yesterday randomly. Not well, I guess it was kind of random. And yeah, they had like this like a table out with like the boys stuff, and they were like, "Oh yeah, he was here earlier today," and I was like, "Okay." So if I'd arrived like 2 hours earlier, I literally would have met the boys writer. Although I wouldn't have recognized him, because I haven't read the comics, and I'm not familiar with Garth Ennis. But yeah, he's literally been to Liverpool, so that's awesome. Holy moly. I mean, like, if I'd seen him, I don't know what I would have done. I probably wouldn't have bought a comic because they're quite expensive and I can't really afford it at the moment. But yeah, that was just crazy. Anyway, I'm going to be continuing this now, Crafting Interpreters. I don't know why I'm on the homepage. I was literally... Okay, yeah, I don't know why... Anyway, in the last video I finished, I think 1 and 2. I thought that was it, the first 2 chapters, but no, there's also another one called the Lox language. But you know, I kind of thought I would just group these together and whatnot. I mean, I'm not really like ordering these videos. I mean, there's an order. I'm not planning these videos out, these recordings, these sessions, you know, for like particular chapters. I'm just going to go as far as I can in a given session. But yeah. But I will, yeah, there's nothing else to say about it. So the Lox language, to give you a bit of a recap, I've decided I'll be doing Rust instead of Java, and I'll be doing Zig instead of C. Now, I won't get to Zig for a while, so we'll start with Rust, and maybe my opinion will change then, but I do want to start with Rust for the Lox language. Let me just zoom in here. And yeah, I'm just going to keep reading. I've got my notes for an Obsidian over here. Crafting Interpreters by Robert Nystrom. Oh, by the way, just a little aside, I haven't updated my Zellocaster in quite a while, with like more topic notes. So I should do that one of these days, but anyway, these are all my notes so far. Most of them are just like definitions and things, and yeah. I'm only taking notes on stuff I don't already know. That's another thing to keep in mind. So I will not be like, you know, like these notes will be like comprehensive or anything. Like it'll be very much what I need. Wait, hold on, what? I assume you guys can read this. C math in C++ is supposed to be compile time as of C++ 23 and 26. But like, does that mean the standard just says, yeah, make these compile time? You know, and then it's like the devs have to figure it out, because I assume it's not particularly easy. I see. Anyway, that was a misclick. I meant to open this. Chapter 3, the Lox language. So we're going to finally see the Lox language. Hopefully, I mean, this is 15 years old, but hopefully the language is at least mildly interesting, like feature-wise and all that. Okay, right. What nicer thing can you do for somebody than make them breakfast? What's the relevance of that quote? We'll spend the rest of this book illuminating every dark and sundry corner of the Lox language, but it seems so cruel to have you immediately start writing out code for the interpreter without at least a glimpse of what we're going to end up with. I agree. Is that enough? Yeah, I'll just zoom in as much as I can, really. At the same time, I don't want to drag you through reams of language lawyering and specificationese before you get to touch your text editor. So this will be a gentle, friendly introduction to Lox. It will leave out a lot of details and edge cases. We can point to that for those later. A tutorial isn't very fun if you can't try the code out yourself. Alas, you don't have a Lox interpreter yet since you haven't built one. Fear not, you can use mine. Okay. Why did I just redirect me to the... No. What? Do I have to buzz it myself? Okay. I can't be arsed. Hello, Lox. Hello, world. Hello, Lox. Here's your very first taste of Lox. Print Hello, world. Your first taste of Lox, the language, that is. I don't know if you've ever had the cured cold smoked salmon before. If not, give it a try too. Oh, so Lox is named after a fish dish. I'm surprised it's not named after a bird. I do wonder what the motivation is behind this. I guess he wants to make it like sea-like. Just so, you know, just because like that's what most compilers would be implementing. So that's already a good thing like to get used to. C-like, like making C-like language parser. What am I saying? But then also changing it in some ways. I don't know. As that /line comment and the trailing semicolon imply, Lox's syntax is a member of the C family. Wow. There are no parentheses on the string because print is a built-in statement and not a library function. I see. So you got built-in statements too. Okay, I see. And I won't claim that C has a great syntax. If you wanted something elegant, we'd probably mimic Pascal or Smalltalk. Pascal looks very C-like. Is this C? This isn't Pascal. This is Pascal. Right. Looks more like Python, yeah. And Smalltalk. I've actually never seen Smalltalk. Well, I probably have, but I can't remember Smalltalk. Oh no! I just know that C++ is inspired by it. Okay. Is that elegant? What C-like syntax has instead is something you often find more valuable in language: familiarity. Yep, exactly. I know you're already comfortable with that style because the two languages we'll be using to implement Lox, Java and C, also inherit it. Yeah, so I was right. I'm surely biased, but I think Lox's syntax is pretty clean. C's most egregious grammar problems are around types. Dennis Ritchie has this idea called declaration reflex use, where variable declarations mirror the operations you would have to perform on the variable to get to a value of the base type. Clever idea, but I don't think it works out great in practice. And Lox doesn't have static types. What are static types? Oh, like oh, because it's interpreted, right? Of course. So this was the idea. A pointer to a 10-element array. Lots of int pointer. Okay, to be fair, this is your fault. Just do int pointer and then p, but okay. But yeah, I do understand. So what's the idea? The idea is that you need to follow those steps. So there's an int of... This is a function, right? Okay, anyway. A high-level language. While this book ended up bigger than I was hoping, it's still not big enough to fit a huge language like Java in it. In order to fit two complete implementations of Lox in these pages, Lox sounds pretty compact. While I think of languages that are small but useful, what comes to mind are high-level scripting languages like JavaScript, Scheme, and Lua. Of these three, what does Scheme look like? Like, oh right, it's fucking... what's the word? What's the word I'm looking for? Lisp. There you go, Lisp. It's very Lisp. Of those three, Lox is most like JavaScript. Scoping, Hues closer to Scheme. Okay, I don't know Scheme. The C flavor of Lox will build in part 3 is heavily indebted to Lua's clean, efficient implementation. Okay. Lox shares two other aspects with those three languages. Hold on. Now that JavaScript's taking over the world and is used to build general applications, it's hard to think of it as a little scripting language. In 10 days, yep. Wants a cute little language, you could call it that. Because H slapped JS together with roughly the same materials and time as an episode of MacGyver, it has some weird semantic corner to the duct tape and paperclip show through. Okay. Lox share, right, so dynamic typing. Lox is dynamically typed. Variables can store values of any type, and a single variable can even store values of different types at different times. Yeah. They don't outweigh the pragmatic reasons for types of Lox. Pragmatic reasons. A static type system is a ton of work to learn and implement. I see. Okay. So this book doesn't go over static type systems, which is a bit unfortunate, but obviously you can have that as a next step, so that's fine. Okay, I understand. After all, the two languages we'll be using to implement Lox are both statically typed. Yeah. What about it? Automatic memory management. Okay, so we got garbage collection. Yeah. High-level languages exist to eliminate error-prone low-level drudgery. And what could be more tedious than managing memory? No one rises and greets the morning sun with, "I can't wait to figure out the correct place to call free." I mean, if you think about it, Rust's borrow checker is almost like a compile time garbage collector. I mean, not really. It's a garbage checker, but I digress. There are two main techniques for managing memory: reference counting and tracing garbage collection. Reference counting. So reference counting is what Rust kinda does. You can also do it for C++ smart pointers is what comes to mind for reference counting though. Ref counters are much simpler to implement. I think that's why Perl, PHP, and Python use them. Over time, I started out using them. The limitations of ref counting became too troublesome, and ended up using a full tracing GC. I do wonder why you can't just do reference counting for a language like Python. In practice, ref counting and tracing are more ends of a continuum than opposing sides. Most reference counting systems end up doing more sub-tracing to handle cycles, and the right barriers of generational collector look a bit like retain calls if you squint. That's a unified theory of garbage collection. Awesome. Thank you, IBM. Tracing garbage collection has a fierce reputation. It is a little harrowing working at the level of remembering. Hard to debug. Remember this because by just spelling magic and saying those monsters. We're gonna write one, okay. We're gonna write a garbage collector. Holy moly. Holy evil. Okay. I guess. But yeah, I do wonder why a garbage collector is seen as necessary. And why a language can't... I mean, like, Rust has the borrow checker, but even besides that... Well... Okay, actually, I can see. Data types. The atoms that make up all matter are the built-in data types. You got booleans, the yin and yang of software, and true and false. Unlike some ancient languages that repurpose... Okay, that's not true, actually. Yin and yang is not true and false. Not to get nitpicky. We may be able to get up on this expedition. We aren't savages. There are two Boolean values, obviously, true and false, okay? George Boole. Oh, Booleans are named by George Boole. Which is why Boolean is capitalized. That's a bit evil. He died in 1864, nearly a century before digital computers turned his algebra into electricity. And they saved it for true and false variables? I mean... I guess what else would you call it? A switch. Or a flag. Huh. That is an interesting argument. For some reason I've never thought about why it's called Boolean. Although I did know about George Boole, just like didn't really think about it that deeply. So let me take a note on that. Data types. Boolean is named after... Okay. Boolean is named after George Boole. Lox only has one kind of number, double precision floating point. I did the same thing for my calculator, yeah. In fact, I also had, I did have booleans in my calculator too, but they represented ones and zeros. Like they were equivalent to 1 and 0, I think. I might be wrong about that. I mean, it doesn't matter actually. Since floating point numbers can also represent a wide range of integers that goes with a lot of territory, yeah. Full-featured languages have lots of syntax for numbers, hexadecimal, etc. We will use basic things. We've already seen one string literal in the first example. Like most languages, they're in close and double quotes. Yeah. There is a lot of complexity. I know, yeah, quite a bit about this. I mean, it's... Well, there's two sides to the complexity of strings. The first one is how they are represented in memory, how they're allocated and all that. Because like a string could be a simple char array, it could be a it could be a null terminated string, it could be a string that is sized like a fat pointer. Strings, usually when you use them, they're compiled into the binary rather than constructed at runtime, which means, like, by binary I mean the executable, which means you need to consider like having static? I don't know, but like const and mutable and non-mutable strings, right? That's really important. And then you think encoding, which is the other side of things, where it could be a char array, but like what if it's a UTF-16, not UTF, but it's just like a 16-bit char or 32-bit char, or maybe it's UTF, Unicode, where you have varying string lengths. UTF-8, despite its name, that does not mean that everything is 8 bits. Every char is 8 bits. It just means actually, what does UTF-8 mean? Yeah, I don't know why it's called UTF-8, but they can vary between 8 to 64 bits. So it's quite, because you have that adds more complexity to strings. Even the word character is a trickster. Is it ASCII? Yep. Unicode, a code point, or a grapheme cluster? How are characters encoded? Is each character a fixed size, or can they vary? And the standards matter, There's one last built-in value who's ever invited to the party, but always seems to show up. Null, or null. So it does have nil. How controversial. I do wonder what challenges implementing nil will arise, or whatever. There are good arguments for not having a null value in a language. Okay, there you go then. Since null pointer errors are the scourge of our industry, if you were doing a statically typed language, it would be worth trying to ban it. In a dynamically typed one, though, eliminating it is often more annoying than having it. Right. I understand. Expressions. If built-in data types and the literals are atoms, then expressions must be molecules. Most of these will be familiar. Arithmetic. Yep. I'm kind of trying to like skim through this because it's kind of just giving a rundown of the language. It'd be very C-like. You got operands, which, fun fact, the word operand comes from mathematics. I mean, I fucking knew that as well, but like, it's easy to forget. Binary operators, you also have infix operators. Sorry, these are infix, but these are prefix. You have binary operators, but also unary operators, ternary operators as well. Those. Well, it's not really ternary. Like ternary is more like a set of operators because it usually uses 2 or more. But like this is ternary, right? Or ternary, sorry, is the word. There are some operators that have more than 2 operands. Yeah, I can see this one. Some call these mixfix. They're fixity. Okay. One is both an infix and a prefix. The negative number. I had to do this for my calculator. Comparison and equality. Yield comparison operators. Anything about truthiness, JavaScript truthiness is not quite the same as other languages. Okay, never mind. They're against implicit conversions. Here, ye. Logical operators. They not operator. Yep, which is false. This one was quite difficult to implement in my calculator, but I got it working eventually. And I think I used a different symbol as well. I might have used. Did I? I actually can't remember now. Maybe I didn't. But this logical operators really are in control field constructs in the guise of expressions. And cool. So we're using actual words here, and or, which I do prefer. Lox doesn't use and or for bitwise operators, so if I were to introduce, yeah, makes sense. I also kind of like using words for these since they are really control flow structures and not simple operators. Yeah, me too. Because you read them like words. The reason and or are like control flow structures is that they're short circuit. Not only does and return the left operand if it's false, it doesn't even evaluate. Yeah, okay. Short circuit, I would call them lazy. But I guess short circuit is another name. Precedence and grouping. Is lazy? I guess this is noteworthy. I don't really know. What section is this? Expressions. Logical operators. Another word for lazy in the context of expressions is short circuit. Precedence and grouping. All these operators have the same precedence and associativity. Okay. Yep. Systems are very interesting. I'll cut the remainder. No bitwise shift, modulo, or conditional operators. Okay. Okay. There we go. Statements. Right, so this is where things get different. I had statements in my calculator for defining variables, but that's it. And the way I implemented them were kind of like outside of the other system. Like I didn't have a binary or like an AST for statements. I just said like if it starts with a let, then just define a variable, and like that was it. So it was very straightforward. But for more complex languages and syntax, you obviously need a bit more than that. Okay, so an expression's main job is to produce a value. A statement's main A statement's job is to produce an effect. Okay, so a statement's job is to produce an effect, whereas an expression produces a value. This is a pretty good way to think about it. Maybe. I don't know. I don't know if that's true or not, but I will keep that in mind. So, effectful... So, okay, that's interesting. So, like any functional programming language only has expressions for that reason. That's not entirely true, but like a function can only contain an expression is what I mean. It can't do anything else, so no side effects. Obviously, a return statement is a statement, but that's if it has a return statement. Functional languages tend to not have those, they just contain an expression. A print statement divides a single expression and displays the result to the user. You've also seen some statements like this, followed by a semicolon promoting expression to statementhood. That's called an expression statement. Okay. Oh, cool. So one of the reasons that we have print as a statement here is so we can start printing stuff in our language before we even have functions implemented, which I think is quite handy. I wonder if other languages have something like that. Like, does C have like a... Well, no, it doesn't. I'm sure I would know about it. And if it does exist, then I will stay clueless. If you want to pack a series of statements where a single one is expected, you can wrap them up in a block. Okay. I'm not sure that's an accurate way to talk about that. Blocks also affect scoping. Yeah. Variables. Scoping will be interesting. Variables, you declare variables using var statements. If you omit this initializer, the variable's value defaults to nil. Okay. Yeah, because otherwise you'd have to have default. Just okay. So basically everything's just optional. It's an optional type. Once declared, you can naturally access and assign a variable using its name. Can you tell that I tend to work on this book in the morning before I've had anything to eat? Har. I won't get into the rules for variable scope here, but because we're going to spend a surprising amount of time in later chapters mapping every square inch of the rules, in most cases it works like you would expect in Java. Okay. Control flow. We already have and or for branching, and we could use recursion to repeat code, so that's theoretically sufficient. But the goal isn't to create a Turing-complete language. It would be pretty awkward to program that way in an imperative style language, though. Scheme has no built-in looping constructs. It does rely on recursion for repetition. Yikes. Smalltalk has no built-in branching constructs and relies on dynamic dispatch. Huh. An if statement executes one of two statements based on some condition. A while loop executes the body repeatedly as long as the condition expression and values are true. I'm sorry, I've heard of dynamic dispatch in a different context. I don't know. I left do while loops out of locks because they aren't that common. I wouldn't teach you anything. Okay. And we have for loops, which we are doing. Okay, cool. This is a concession I made because of how the implementation is split across chapters. A for in loop needs some sort of dynamic dispatch in the iterator protocol to handle different kinds of sequences. But we don't do that until we're done with control flow. Okay. I mean, like, all these things where it's like, you can add them yourself later if you want to. I'll just say for a different language when I actually get around to making a proper one. Dynamic dispatch. Yeah, it's for like classes and stuff. Oh, okay, I kind of see where that's going. Functions. A function call expression looks the same as it does in C. Can be empty. In Ruby, the parentheses are mandatory. Unlike Ruby, sorry. If you leave them off, the name doesn't call the function, it just refers to it. Which is, I believe, the correct way to go about it. A language isn't very fun if you can't define your own functions, and lets you do that with fun. Fuck! Dude, fun is my least favorite one. Because, like, it reads like a different word. FN, fun, func, and function. Funct, functi, or functio. What's that, what's that language? Like, do I have it bookmarked? Probably don't. But, like, it supports all of them, which is funny. Well, any... Yeah, anyway. Low-key, if a language had funct and funct IO, that'd be kind of genius. Hold on. Let me share this revelation. I have had an epiphany. No more FN. Instead have funct for pure functions and functio or funct for impure functions. This might be the single greatest idea I've ever had. Let's going to clarify some terminology. Some people throw around parameter and argument like they're interchangeable. They aren't! And this annoys me too. And to many, they are. We're going to spend a lot of time. Okay, some of the time study here is on semantics. An argument is an actual value. The parameter is the variable that holds the value. Damn straight. Thus, a function declaration has a parameter list. Others call these form parameters simply formals. Okay. Some statically typed languages like C make a distinction between declaring a function and defining it. Yep. If you declare a function, you are simply stating it exists. If you define it, you give it a definition, right? A definition declares a function. Okay. Since Lox is dynamically typed, this distinction isn't meaningful. Okay. The body of a function is always a block. Inside it, you can return a value using a return statement. I'm thinking, I'd actually argue even further here that a parameter isn't a variable. The parameter is the interface. Like, when I point to a function's parameters, I'm pointing to the variables. But when I'm using the variables in my code, I don't say I'm using the parameters, I say I'm using the arguments. Because, like, I'm kind of like... Because, like, the parameter is like like the blueprint. If that makes sense. But like when I'm using the variables, I'm using the values that are in them, therefore I'm using the arguments. That's how I think about it. And if execution reaches the end of the block without hitting a return, it implicitly returns nil. So nil's like void. Okay, nil's doing a lot of heavy lifting. Closures, lambdas. Functions are first class in locks. That's cool. which means they are real values that you can get a reference to, store in variables, pass around, etc. This works. Identity, passing in add pair, and then calling it. Okay, that's cool. Since function declarations or statements, you can declare local functions inside of the function. I mean, I don't blame you if you don't like this, and I also don't like it, but yeah. Yep. I'm trying to think. What's the other way to do this? Can't remember. Ooh. Okay, like Python. I do wonder why languages like C don't allow this. Yeah. If you combine local functions, first class functions with block scope, you run into this very interesting situation. Inner, print outside. Is this kosher? What? What's kosher mean? Foods that conform to Jewish law. Is this like saying, is this haram? But like it's Jewish? What the fuck? Jewish propaganda in my coding guide. Return function, var outside equals outside, return inner. Oh, I see what it means. Okay. I think that's not bad. If that's to work, inner has to hold on to references to any surrounding variables. Yeah. Oh, that's what they call closures, okay. PTOJ landing equivalent to closure. Yes, he mentioned damn near half the terms in programming languages. Most of them came out of one incredible paper, the next 700 programming languages. Please have it not be a dead link. Let's go. Okay. In order to implement these kind of functions, you need to create a data structure that bundles together the function's code and the surrounding variables it needs. He called this a closure because it closes over. As you can imagine, implementing these adds some complexity because we can no longer assume variable scope more strictly, like a stack where local variables evaporate the moment the function returns. We're going to have a fun time learning how to make these work correctly and efficiently. I don't understand. The local variables do. How is it not a stack? Because this is still in scope of this. So I don't see what the issue is here. Actually, no. Maybe I'm just not seeing it correctly. As you can imagine, implementing these adds some complexity. I just read that. Classes. Ooh boy. I don't understand why people treat object-oriented programming and functional programming like they're mutually exclusive. Like, object-oriented programming just has objects, and functional programming just has pure functions. Like, those, like, objects and pure functions are not, like, they're not incompatible. If anything, in functional programming, it just means that everything is static, or like const. And static, yeah. Like, just static classes. So I don't know. Like whether or not your object orientation, whether or not your OOP has mutation, is not particularly tied to the idea of OOP anyway, at least from what I understand. Why might the language not be object oriented? Note that now that object oriented languages like Java have sold out and only play arena shows, it's not cool to be like them anymore. Why would anyone make a new language with objects? That's a good question. It is true that all inheritance. It is true that the all inheritance all the time binge of the 90s produced some monstrous class hierarchies, but OOP is still pretty rad. Yeah, but Rust does it much better. Billions of lines of successful code written in OOP languages, shipping millions of apps to happy users. That's a pretty bad argument. Likely a majority of working programmers today are using an object-oriented language. They can't all be that wrong. That's also not a good argument. But in particular for a dynamically typed language, this is literally, what the fuck? It's just like a challenge of like, spot the fucking fallacy. In particular for a dynamically typed language, objects are pretty handy. We need some way of defining compact data types to bundle blobs of stuff together. Yeah, they're called structs. If you also hang methods off of these, then we avoid the need to prefix all of the other functions with the name of the data type they operate on to avoid cladding with similar functions for different types. In say Racket, you end up having to name your functions like hash copy and vector copy, so they don't support each other. Methods are scoped to the object, so the problem goes away. Yeah, so you got name spacing. Yep, which again is why you can have classes in functional programming. I mean, they exist, they literally exist, but like they're just structs. And it's annoying that you can't tie functions to classes in many functional languages, because it just means that you have a namespace problem for no reason. So that it just annoys me that people treat them like, again, they're mutually exclusive. They're not. They're different things. You know, it's like having color-oriented programming and number-oriented programming. Like, I can mix numbers and colors. Like, they're not the opposite of each other, is what I'm trying to say. I do wonder. I mean, the main thing, obviously, is not having inheritance. And instead having, well, as Rust calls them, come on, the word implementations, or no, what's the word? What's the word? I can't remember what the word is. I'm dying right now. Traits, yeah, trait system. Oh, Jesus Christ. That's the main thing. If you also hang off methods off of these, okay, why is Lox object oriented? I can claim objects are groovy, but still add a script for the book. Yeah. Must PL books. Leave objects out. To me, that means the topic isn't well covered. Okay. Given how many of us spent all day using OOP languages, it seems like the world could use a little documentation on how to make one. Fair enough. Okay. And then classes are prototypes. When it comes to objects, there are usually two approaches. Classes, prototypes? I've never heard of prototypes. Classes came first and are common thanks to C++, Java, etc. Prototypes were a virtually forgotten offshoot until JavaScript took over the world. What are prototypes? In class-based languages, there are two core concepts: instances and classes. Okay? Classes contain the methods and inheritance exchange. You call a method on an instance, there's always a level of indirection. You look up the instances class, and then you find the method there. You look up the instances class, and then you find the method there. Yeah? In a statically typed language, method lookup typically happens at compile time. This is just static dispatch. In contrast, dynamic dispatch looks up this class of the actual instance object at runtime. For virtual methods. Right. Prototype-based languages merge these two concepts. There are only objects, no classes. And each individual object may contain state and methods. Objects can directly inherit from each other or delegate to. Oh, I've seen this in JavaScript, yeah. In practice, the line between class-based and prototype language blurs. Prototype language just kind of sucks. Okay, this means that in some way, prototype languages are more fundamental than classes. They also really need to implement because they're so simple. Also, they facilitate usual patterns. Yeah, I mean, it's interesting, but I think traits as building blocks are just better. Yeah, but I looked at a lot of code written in prototype languages, including some of my own devising. They use them to reinvent classes. I don't know what that is, but people naturally seem to prefer a class-based classy style. Prototypes are simpler in the language, but they seem to accomplish that by only pushing the quality of the user. The waterbed theory. System complexity is essential and cannot be eliminated. If you push it down in one place, it starts with another. Okay. Prototypal languages don't so much eliminate the complexity of classes, as they do make the user take the complexity by building their own class, like many programming libraries. Yeah. A good argument against like building block things, yeah, I guess. Building things into the language directly can be more useful. Classes and locks, and of rationale, let's see what we actually have. Classes encompass a constellation of features in most languages. For locks, I've selected what I think are the brightest stars. So there's no public private. The body of a class contains its methods. They look like function declarations, but without the fun keyword. I just realized, where are the return types? Are they just implicit? I mean, these are void, but when the class declaration is executed, locks creates a class object and stores that in a variable named after the class. Just like functions, classes are first class. I mean, okay, so it's like a constructor. I'm sorry, are we storing the class or an instance? It's an object, so that is actually quite bad. That is quite terrible. Next, we need a way to create instances. We could... No, it is this. So it's more like an alias then. I wonder why. We get some sort. I wonder why it's like this. New keyword, but it's simple. And locks the class itself as a factory function, for instances. Call a class like a function, so it's a constructor. Okay. Instantiation and initialization. Encapsulate behavior and state together. You need fields, so you get variables, right? Serve who. Okay. Where? What? Where are the variables? I assume that they're defined here somewhere. Inheritance. Every object in your languages lets you not only define methods, but reuse them across multiple classes or objects. For that, Lock supports single inheritance. When you declare a class, you can specify a class that it inherits from using a less than operator. I mean, yeah, inheritance. It is what it is, right? I will say, using the less than operator is interesting. Not because of like the arrow or whatever, but I like it because it keeps the concept that... Actually, fuck no, it's actually backwards. I was going to say, like, because brunch inherits from breakfast, breakfast is less than brunch, because breakfast has less than brunch does. But this is actually the opposite, so I don't even know. They don't want a new keyword like extends. Lox doesn't use colon for anything else, so I didn't want to reserve that either. What? What? Bro, make it make sense. Because this operator was left unused and could therefore be used for this unique feature, I decided to reuse an existing operator instead to make it more confusing. Okay, when I do this, I'm gonna use a different fucking symbol, bruh. If you know any type theory, in fact, I might just use the word extends. I think that's fine. If you know any type theory, you notice it's not a totally arbitrary choice. Every instance of a subclass is an instance of the superclass. But there may be instances of the superclass that are not instances of the subclass. That means in the universe of objects, the set of subclasses objects is smaller than the superclasses set, so the type nerds usually use this for that relation. So if breakfast is a member of brunch, but that's not the case though. It derives from brunch, and they can have more stuff. Like, breakfast is a subset of brunch, if anything. So I still think it's backwards, right? But I don't know, it's type theory thing. So here, brunch is a derived class or subclass, and breakfast is a base class or superclass. I don't like the word subclass. Derived class. Even then, I don't like that name. It just derives from breakfast. It's not the derived class. It's just the class that derives from breakfast and could also derive from other things, right? But I mean, that's like single inheritance though. I mean, C++ supports multiple inheritance. Really, inheritance is just an evil feature, bruh. Trace is better. Every method defined in the C++ class is also available to its subclasses. Lox is different from C++, Java, and C#, which do not inherit constructors, but similar to Smalltalk and Ruby, which do. I haven't really used inheritance much in C++ lately, so I can't even really speak for that. Constructors are not inherited. Yeah. And they can't be, because again, they have multiple inheritance. At least in C++. C#, I can't remember if it does or not. Even the init method gets inherited in practice. What's init? Is that the constructor? I'm confused now. That's different, isn't it? In practice, the subclass usually wants to define its own init method too, but the original one also needs to be called so the superclass can maintain a state. So it goes super. Okay. I guess. So that's about it for object orientation. I tried to keep this feature set minimal. Lox is not a pure object-oriented language. In a true OOP language, every object is an instance of a class. There's no need for that. Values are primitive types on real objects in the sense of being instances of classes. They don't have methods or properties. I would fix that otherwise. The standard library, we're almost done. This is the whole language. So all that's left is the core or standard library. Usually a standard library is implemented in the language itself, so that'd be interesting. The set of functionality that is implemented directly in the interpreter, and that's all used. Nihilism, what? For the time in the book, you only need to demonstrate the code is running and doesn't know what it's supposed to do. For that, we've already have the built-in print statement. Later, when we start optimizing, we'll write some benchmarks and see how long it takes to execute code. That means we need to track time, so we'll have clock. Okay. And that's it. If you want to unlock to an actually useful language, you would have functions and stuff, but we don't need any of that, and it's not even really a part of the compiler development, unless you want to have like built-in things. But challenges: write some sample logs programs and run them. Unspecified. Tiny language. Okay. Logs is both expressions and statements. Some languages omit the latter. Yeah, I really don't like the everything as an expression. Way to go. I think it's interesting, but like as a practical language, I don't like it. Again, it's like, because then you need to basically create statements from expressions, and that's like kind of the waterboard effect, where you just, why do you waterboard? Holy waterbed, where like you're just handing the complexity to the user instead. Don't like it. I mean, that's why Haskell has do notation, right? To do that, for each statement, like constructing the language, you should decide what value it evaluates to. An if expression evaluates the results, whichever branch is chosen. In CoffeeScript, a while loop evaluates an array containing each element that the body evaluated to. Wow. What? Okay. You also have to, I mean, like, I understand what it's doing, but I don't know why I skimmed to a while loop of all things and not like some function or something. Like in Haskell, you have, I think it's scan will keep track of it in an array. Something like that. You also have to decide how the statement-like expressions compose with other expressions. Puts 1 plus if true, then 2, else 3, and fucking hell. Turning a statement into an expression forces you to answer a few hairy questions. Implicit returns. Okay, well, that's the language. I said I would replace the less than sign, but I guess I'll just keep it to be faithful. That's probably the most important thing. A tree walk interpreter. Right, we're finally on section 2. Let's go. Where is the table of contents? Is there like a way to get back to them? Up. Right. So this isn't a chapter. This is the section? The fuck? With this part, we begin RSLox, the first of our 2 interpreters. Okay, let's go. Scanning. Tokenizing. Ah. How long is this section? Decently long. Okay. Because like I would expect it to be. Take big bites. Anything worth doing is worth overdoing. These quotes are like really not meaning much. The first step in any compiler or interpreter is scanning. The scanner takes in raw source code as a series of characters and groups it into a series of chunks we call tokens. These are the meaningful words and punctuation that makes up the language's grammar. Awesome. So I want chapter 4, scanning. I don't know if I'll even have many notes for this one because I'm already decently familiar with scanning. But we'll see. I'm just gonna unify that. Right. Scanning. Sorry, this task has been variously called scanning and lexing, short for lexical analysis. Way back when computers were as big as Winnebagos. What in the world? Okay. That's cool. I want one of those. But less memory than we will watch. Some people use scanner only to refer to the piece of code that dealt with reading raw source code, characters from disk. Lexing was a subsequent phase. So why are we calling it scanning here? I don't know. It's more like scanning, which is really fast now. It should be called lexing. As far as I'm concerned, it should be called lexing. Or tokenizing. Scanning is a good starting point for us too because the code isn't very hard. Just for a statement. Pretty much, yeah. The hard part is... actually, how did I do it in C++? I'm actually curious now. I did start making a C++ calculator. I didn't finish it though because I kind of just got like bored, quite frankly. And the ergonomics weren't very fun, so... repos... Calculator... I did start making it in Rust, right? Did I make a tokenizer in Rust yet? I'll have a quick look. Also, let me look at my OCaml calculator so I can remember what features I had. This is Rust 1. I didn't get very far with the Rust 1 yet. And I probably won't. But maybe I will. One day. So here's the tokenizer. Just uses enums. The thing is, tokens can contain data, which is where having Rust enums comes very handy. But yeah, I mean, it was just a while loop with a match statement, right? So then for the C++ one, how far did I get? I did not get to the parser apparently, but I did get to tokens. For tokens, I had enums, for operators and stuff like that. I overloaded this so I could just have it be string, like I can't think right now. I did it so that I could output it, I think. Yeah, standard cout. Why did I do that? Because I couldn't use format or print. Yeah, that's right. I couldn't use standard print because I did this on Windows and that hasn't been implemented yet. Good stuff. Anyway, as you can see, I need to have my own class for a token, which contains a it's a tagged union is what it is. And you can see I have the union somewhere here. If I were to do this again, I'd do it a bit differently. I'd use a standard variant, but it's just such a pain in the ass. I now use tagged unions with variants and visitor syntax. I do that for my error handling in my libraries, like my NUCC library and my binary libraries, these two. But we'll get pattern matching soon as well, so that'd be nice. But anyway, otherwise, yeah, the actual, apart from that, faffing about, the actual tokenizing itself is fairly straightforward. But again, that's for a calculator. For OCaml, let's have a look real quick. Yeah, so I had this for expressions, where you just stored it into your variable, very simple. I had, constants and functions. This was the output. You can see I have a tokens, and then I have an abstract syntax tree. Very cool. It's an OCaml, so all of this is formatted for me. I like it. Yeah, this operator as well, which allowed you to chain expressions for like one-liners, like x, like store 5 in x, store 3 in y, and then do x times y. Yeah, honestly, pretty cool. This was fun to make. I didn't love OCaml. OCaml was a very strange language, but just like making the compiler itself was very fun. The tool itself was very fun, and you can see I added like a bunch of operators, factorial and XOR and exponentiation, even a percentage thing instead of using it for modulo. Variables, constants, built-in functions like absolute value, sine and cosine, very important, right? I thought about using like logarithm, like adding log and stuff, but yeah, I kind of lost motivation to continue. But this was very fun. This was a very fun project. And I think is this a binary of the actual calculator? Yeah. So that was cool. Maybe one day I can make like a tutorial for how to make this. But there are booleans though, aren't there? I could have sworn I had booleans. Because you have like no, there are booleans. Yeah, so they're the constants true and false. Here, oh yeah, true and false, which like I said, just evaluate to 1 and 0. So I mean, it's a calculator, so you're not gonna have different types. Everything's gonna be a number one way or another. Anyway, okay. The interpreter framework. Since this is our first real chapter, before we get to actually scanning some code, we need to sketch out the basic shape of our interpreter, RSLox. Everything starts with a class in Java. Lox of Java, create a new file. System exit 64. So it might be like an early return. Else if args.length equals 1, run file, else run prompt. What are we doing? For exit codes, I'm using the conventions defined in Unix sysexits. It's the closest thing to a standard I could find. I mean, I don't think most languages even use exit codes, like in their language, because it's so non-standard. Like at least like not like in their main function explicitly. Like in Rust, the main function is void, is what I'm trying to say. I mean, you have Linux convention. Stick that in a text file and go get your IDE or makefile. I'll be right here when you're ready. Lox is a scripting language, which means it executes directly from source. Our interpreter supports 2 ways of running code. If you start from the command line and give a path to your file, it reads the file and executes it. Okay, if you want a more intimate conversation with your interpreter, you can also run it interactively. Fire up RSLox with no arguments, as you could one line at a time. Cool, I guess. An interactive prompt is also called a REPL, pronounced like rebel with a P. REPL, okay. The name comes from Lisp. I mean, how else would you pronounce it? REPL. One as in as simple as wrapping a loop around a few built-in functions: print, eval, read, working outwards from the most necessary call. You read, evaluate, print, and loop. So that's why it's called REPL. Okay. I mean, I've literally only ever heard that term used on REPL.it, like Italy, I guess. What the hell? The readline function, raise a line. Then you have run, which generates a list of tokens, tokenizes, and prints them. Okay, then for error handling, the tools our language provides for dealing with errors make up a large portion of its user interface. When the user code is working, they aren't thinking about our language at all. Their headspace is all about their program. It's usually only when things go wrong that they notice our implementation. Right. Yeah, how do you get the line number, actually? I do wonder about that. Not very helpful, we need to at least point them to the right line. I'll have to remember some of that in this book, but the honest truth is... Oh wait, this is for our language, yeah, never mind. Okay. I think it's interesting. My calculator had very minimal error reporting, but enough to, to tell you when you fucked up. We'll use this to ensure we don't try to execute the code that had a known error. It's good engineering practice to separate the code that generates the errors from the code that reports them. Uh-huh. Ideally, we would have an actual extraction, some kind of error reporter interface. I didn't do that. Okay. Right. He avoids keyword for taking a variable. That 3-character sequence VAR means something. But if we yank 3 letters out of the middle of a language, like GUA, those don't mean anything. Yeah. Our job is to scan through the list of characters and group them together into the smallest sequences that still represent something. Each of these blobs of characters is called the lexeme. So for a lexeme versus a token, I assume a token is like the enum whatever, whereas a lexeme is just like the text. That's what I'm getting from this. So lexemes and tokens. Why is that not a word? A recognized word. Okay. Yeah. Definition. Lexeme is just a string, a sequence of characters representing something meaningful. Something representing what though? Something representing a fundamental building block in a language, or like something atomic, but not really atomic. Anyway, a lem, not quite. Token type. Keywords are part of the shape of the language's grammar, so the parser was good like. That means the parser wants to know not just that it has a lexeme, but that it has a reserved word and which keywords it is. The parser could categorize the tokens from the raw lexeme by comparing the strings, but that's slow and kind of ugly. Instead, at the point that we recognize a lexeme, we also remember that which kind of lexeme it represents. We have a different type for each keyword, operator, but punctuation is no type. After all, string comparison ends up looking at individual characters and isn't that the scanner's job? So we're not doing string comparison. What? Okay. Literal value. There are lexemes for literal values, numbers, and strings. Okay, so let me start actually going into this project here. Right, so we got CD RSLox for Rust. R would just be, what would R be actually? The R language, maybe. And let's open this in NeoVim. Let's try to open this in NeoVim. I have nothing right now, just this main RS, but let's go ahead and define our enum, token, and rather than do this, we're going to split them into different categories since Rust makes it quite easy. Okay, I don't like how these are grouped, but we have a literal, enum literal as well, like we have an identifier. What's an identifier? Is that just like a really identifier in programming? Oops. Oh right, it's a name. So that'll have to be a string. Could use like a UID, but for now we'll do a string. Speaking of which, you have a string literal, which of course contains a string, and a number literal. Hold on, an identifier isn't a literal. I'm gonna remove that. And a number, which in our case would just be a double. So you got literal. We can have identifiers, which contain a string. Really, it should be like an index into a table though of variables would be ideal. But let's say we go for with a map-based approach, or we could hash them. I'll teach you later if I need to. Keyword. Now you'll notice that we have some conflicting casing here, which I'm not a fan of. I would prefer really then if we can make these different. But I think ultimately it should be okay. If I find it annoying, I might well, the thing is, Rust also enforces like naming schemes, so I am not actually allowed to do this without annoying the compiler. But anyway, enum keyword and class else. Why are these in alphabetical order? They are. It's like and class else false fun. I'm gonna implement this language, by the way, like as it says it should be. So I'm not gonna get too opinionated about like naming stuff and whatever. Print return super this true var while. You may argue that I should do it more like this and collapse them, but then it becomes hard to like navigate, so I'll just leave it as it is. And a file. Then we've got these things. I'm just going to leave them for later. Literal value. These are lexemes for literal values, numbers and strings and the like. Location information. Back when I was preaching the gospel about error handling, we saw that we need to tell users where errors occurred. So this is token type, yeah. Checking that starts here. In our simple interpreter, we note only which line the token appears on, but more sophisticated implementations include the column and length too. Okay. So our token enum should really be a token type enum. And the actual class, or struct in this case, the token struct, will contain a token. The thing is, these contain data too. So we'll have a class. A class. No, this is a token. This is like a token, like meta, if that makes sense. Because like the token itself is just the token, but then it also contains other information. So we've got the string, the lexeme. Okay, I don't care about that, but I do care about. Sorry, this is wrong. Token. I think like this, right? So you got pub token token. Sorry, I've been using C++ for days now, so I can kind of like remind myself how this works. I think I need to make it public. I actually can't remember. We have a line number, which is U32. You could argue that number is redundant because you already know it's a U32, but I'm going to disagree. Sorry, the offset from the beginning of the source file and the length of the lexeme. The scanner needs to know this anyway, so there's no overhead to calculate them. An offset can be converted to line and column positions later by looking back at the source file and counting the presented new lines. It is slow. You only need to do it when you actually display a line and a column to the user. Most tokens never appear in an error message. For those, the less time you spend calculating position, the better. Okay. Regular expressions. Oh boy. Oh yeah, we also need a way to convert these to strings, but that'll be okay, I think. Now that we know what we're trying to produce, let's well produce it. The core of the scanner is a loop. Starting at the first character of the source code, the scanner figures out what lexeme the character belongs to. Okay, but then loops back and does it again. So in Haskell you would do this, or Camel you'd probably do this recursively, but we will use a while loop because we're not using a functionals language. And a while loop is looping is just always easier to for me, I think, to comprehend than recursion. I don't like it. Lexical anal egator. Oh. Is that intentional? I will not elaborate. The part of the loop where we look at a handful of characters, figure out which kind of lexeme matches, may sound familiar. Regular expressions. This regex matches 1, a variable name. If you did think of regular expressions, your intuition is a deep one. The rules that determine how grammar, particular language, groups characters into lexemes are called statistical grammar. Right, in Lox as is. Hold on, I should probably write this down. Regular languages and expressions. So a lexical grammar is the rules governing how lexemes are formed from character input. Are grouped, are formed from grouping character inputs. Oh my god, bro, lexemes is a word! You can recognize, hold on, it paints a good cluster with the theory so much, it's as interesting as I think the computational hierarchy and fundamental missions are. The honest truth is other books cover this better than I could. Oh yeah, the Dragon book exists. That's a book I've actually been meaning to read as well. I tried to find it in my university library, but I couldn't I don't think. And either way, it's probably better to read it online. I think it's also like fairly outdated, so, or like dated. I mean, it's literally 1985. So while it's, you know, while it's a cool book, okay, this is 2006, I guess. While it's a cool book to read, I think you can do better with your time, but it certainly is interesting. Nevertheless, maybe one day I'll read it in retrospect, or maybe I won't. In Lux, the rules are the grammar, regular language. That's the same regular as in regular expressions. You very precisely can recognize all different lexemes. There's a part of interesting theory. Yep, Lex was created by Mike Lesk and Eric Schmidt, chairman of Google. Okay, that's cool. So the executive chairman of Google, he was a billionaire, was he? He was someone who created a programming language tool. So isn't that motivating? Since our goal is to understand how a scanner does what it does, you won't be looking at how to score about handcrafted goods. The scanner class. Okay. I know static imports are considered bad style by some, but they are like this. But they save you from having to sprinkle token type over the scanner and parser. Forgive me for every character counts in this book. We store the source code as a simple string, and we have a list ready to fill. So this is inside the class, right? Yeah. Like after the line that says scanner. Okay. So in Rust, this is be interesting. A class. In Rust, a struct can contain methods, but through impl. So we'll have a struct called a tokeniser. I'm not calling it scanner. I don't care. Could call it a lexer, but I like tokeniser because that's literally what it does. It tokenizes, and it will have a source. Arguably not necessary though. I'm sorry, why do we even need a class for this? Like immediately, I mean it's Java, so I guess you don't really have a choice, do you? But like, considering this will literally have one function and all it does is just pass this and then have a return type. Yeah, in this case, I don't think we even need a tokenizer class. Maybe I'll be wrong, but for now, I think we just need a tokenize function. So tokenize, which takes in a source as a, I guess, static string. Strings are in Rust. I haven't gotten used to them yet, so I might probably need to change that. And it returns a list of tokens. In our case, we have errors as well, so it'll be results of a vec of token meta or an error, which I would just call token lexical error. Token error, just token error. Okay. And then you have the implementation there. And this will return, well yeah, that's it. So while, we'll have a while loop. There's a loop thing, isn't there? Yeah, so while not is at end. Okay. I'm not entirely sure that's even calling to. Probably be within there, but while not is at ends, I'll just start equals current. What's start? What's current? What? So did I miss something? No. Okay, this is a really weird way of teaching it, because like he's defining the variables later. But okay. So start equals 0, current equals 0, line equals 1. What does start mean? That name's very cryptic. Okay, let me just read first, because clearly there's no point in just rushing ahead if I don't understand what's actually going on. The scanner works its way through the source code and tokens and other characters. Okay, the loop depends on a couple of fields. The start and the current fields are offsets that index into the string. The start field points to the first character in the lexeme being scanned, and current points at the character currently being considered. The line field tracks what source line current is on, so you can produce tokens that know the location. Okay. So we have a U32 string start. Let would be mutable. String start, or even like lexeme start. I'll do lex for short. Lex start. Lexeme start. Fuck it. U32 equals 0, and lexeme char I, char index, and let mute current line number equals 0 as well. Current is more than equal to source.length. But current is sorry, first character in the lexeme or first character in the entire file? Because this doesn't make sense then. Current more than equal to source.length. No, it would be current. Okay, so that's just wrong. It's the start of the input, which is obviously 0. I cannot wrap my head around this. How does this make sense? Whatever, I'll just make another variable. Let's mute index. I know it's a very vague name, but I'll fix it later. And then we're going to check while. Not even. In fact, not even. I can just do for index. or for I, in 0 to source dot length or len. I don't know what the thing is in Rust. I'll figure it out later. Well, not necessarily, to be fair. No, actually, that's not true at all. For let mu I, well, I mean, not, okay, whatever. For let mu I, u32 equals 0. And what I'm assuming u32 is the largest it can be for now. I will do a while loop. Because we might advance I more than once. So. Within a single iteration. Recognizing lexemes, in each turn of the loop you scan a single token. This is the real heart of the scanner. Well, first simple. Imagine if every lexeme were only a single character long. Like in a calculator. Very easy, right? Okay, so we're going to start with those apparently. Char C equals advance. Advance is the next one. Like, wow, so cryptic. So we're going to scan token. So we say char, sorry, C. Let's see char equal the next char. Well, no, that should be the end, shouldn't it? I was using plus plus. Fuck, you know. Evil. Okay. Right, so if it's a just like this, isn't it? Yeah. Then we're going to tokens is a vec of token meta. Yeah, so do tokens dot push token left paren. So we need to add that as well. This was like brace and stuff. Leave for now. Right, so you got that. Then you have right paren. I actually like this name. I like start paren, or paren start, and paren end. I think those are better names for what they actually do. Paren start, paren end. And then same thing, but just with other ones, right? I think there's only two types of parentheses in this. Braces. So brace start. Okay. Oh, got two pings here. This guy does not like it. What the hell? Okay. Where am I? Yeah. Okay. Comma. I don't know what to call it yet. Period. They call it a dot. I'm not going to call it a dot. Call it a period. Minus. Plus. Semicolon. Asterisk. Which some call a star. We do not need a couple of helper methods. You're lying. I++. Does that actually work in Rust? I don't think it does. I plus equals 1. In this case, it'd be I plus equals 1. In case you're wondering why I don't do like a normal for loop. Then source, add token, add token. Okay. The amount of the consumers and scatter, blah blah blah. Right, let's click errors. Before we get too far in, sorry, I need to actually. I'm pushing token meta, right? So I need to push like this, I think, with a line number. Apologies. So the poor man's solution would just be to do this. But I'm gonna do something sigma and just ignore it for now because I don't even have. I'm not even tracking the lines right now. Just come at you later. What happens if a user throws a source file containing some characters Lex doesn't like? Right now, those characters get suddenly discarded. They aren't used by Lox language. Okay. So by default, Lox.error. Yeah. Whoops. So by default, or as we put in Rust, this symbol here. This should return token error. Unexpected character. Yep. So I will need a enum token error, which at least contains an unexpected character error. And actually it's probably include what the char is. Note that the erroneous character is still consumed by the call to advance. It's important so we don't get stuck in an infinite loop. Notice that we also keep scanning. There may be other errors in the program. It gives our users a better experience if we detect as many of those as possible in one go. Otherwise, it's see one tiny error and fix it, only to have the next error appear, and so on. I see. So it will continue generating errors, despite this. Which I think is interesting. At some point, that's really like a halting point though, right? Although it's just tokenizing. Controversial, but I really don't mind the whack-a-mole thing. Just because it reduces compilation time between errors. This code reports each individual invalid character separately, so this shotguns uses with lots of errors if it accidentally pastes a big bulk of weird text. Code a single one of invalid characters to a single error would give a nicer user experience. Okay. I could be lazy, but I'm going to do what it says, and instead make it a vector then of errors. So then at the end it can do that. So let mute errors just be a vec of token error, and at the end, if there are lots of errors, then it will return that instead. So token error, tokens dot, sorry, errors dot push, like so. And I'll also make this optional because there's not guaranteed to be it. Now I don't know if this even works. If I have an option vec t, how do I push to the vec? Okay. Get or insert with vec new. I see. So it'd be errors dot get or insert with vec new dot push. I was going to say, I was going to joke that no one calls Rust pretty, but actually no, that's not true. People definitely don't. It looks quite horrendous sometimes. Don't worry, since I had arrow get set, we'll never try to execute any of the code, even though we keep going and scan the rest of it. Right. Or in our case, we just track it with an option. I can make it simpler by having a boolean instead, but like simpler to whatever, but option is more idiomatic. Operators. We have single character lexemes working, but it doesn't cover all Lox's operators. What about exclamation mark? Right. So if we have this, then we need to consider what's going on. Is that recursive? No, it's not. What's match? The next one. Okay, it's interesting. So if we have an exclamation mark, then well, it's kind of just saying this. It's saying match on source, sorry, I plus 1. Where if it's bang equal, sorry, if it's an equal sign, then tokens dot push bang equals. Otherwise, just do bang. Except it also then does I plus equals 1, and if it's out of bounds, then it should also return false. So if I plus 1 is less than source length, then do this. Not the cleanest, I could definitely make this cleaner, but that's the proof of concept. Okay. Right. So already I can start to see how I can abstract some of this away. So I can create a struct, a tokenizer struct. More so just so I have like different functions that can access the same objects, which can be useful. So we'll have a struct tokenizer, which has these how does this work? Do I have to do like this or something? Or is it like pub mute? How do I declare in Rust? Let's see here. In Rust, how do I declare a struct members as mutable? Or is it just tied to the struct itself? It shouldn't be, because you have const in C++. Fuck, man. What? So some things aren't constants. Oh right, because const exists. Never mind. Like this exit. Static. Never mind. It exists, don't worry. Pub tokens, pub errors. Can I have a default initializer? Do Rust structs allow default initializers? On constructor only. Okay. I think option is done by default anyway, so that's fine. But interesting. Impl. Oh. I see. Anyway, impl tokenizer. Just move this inside it. Never say that Rust doesn't have object, well, never say that Rust doesn't support OOP, it just supports it in a much better way. Functions, we pub. Don't need this anymore. This can go here as well. Yeah. I haven't used these yet. I'm just going to delete them until I actually need them. So while I is some sort of length, I'll just do current char index and replace I with that. Holy moly. Right, anyway, okay. So tokens equals vec new. I believe that's correct. I think I need to initialize it. Errors equals none by default. Current line number equals 0, and the current char index equals 0. So that's all our initializers for this function. Then we do this stuff. We have a pub, actually be a private function. So function push token, just add token, take in a token with return type of nothing, is void. It purely exists for side effects. It will do tokens dot push token, so it's token meta, so it'd be token meta, or let meta equal token meta, and I think there are named fields, right? So token is just token and the current line number. Or just do token and then current line number. Is that allowed? I don't know if that's allowed. Man, I really need to get used to this language. Something like this should be correct though. So then we can just replace all our tokens dot push with that instead. So now it actually encodes the line number, and fn is end of input, just is input end. No default arguments unfortunately, but we'll take in hold on, token. This will be an index. Yeah. Boolean, and it just returns index is less than source or length. That's it. Now source is here. So source will be a string reference. I would just say, yeah, source equals source. Give it underscore, so it's like that. Low key, none of these should be public. These should not end with semicolons. So now we just do is input end on this. I think not having default arguments is actually really annoying. Does Rust not have it? Does Rust have default arguments? What does Rust do for default arguments? builder pattern option is actually pretty decent, but you still have to pass in none, which isn't automatic. And there's a default trait. Yikes. Okay. So its input ends at, and then another function is input end. Like this. Okay. So you want this then. Not too bad. Then match source at this. I think I need to write this in the scope. So I want to say let next char index 32 equals, actually probably just let it be inferred, current char index plus 1. So replace the current, replace current char index plus 1 with next char index. Advance cursor, just advance even. I just realized I have to pass this, don't I, as a parameter? Yeah. So it'll be this self. Remind me how Rust does member functions, methods, whatever. That's right. Add self. Tokenize does take it, yeah. Hold on. Yeah. So self, which actually means I don't need this anymore, which is kind of useful. Self. Is it a bit verbose, perhaps, but it is clear. What the fuck? Okay. And for this, it should be mutable self, right? Okay. Yeah. So I mean, if it wasn't obvious, I'm also learning Rust as I do this, so this is quite good. Let's compile. Actually curious. I don't see why I wouldn't. So I'm gonna try compiling just to see what the fuck's even going on at this point. Make CDX first. So cargo build. That was fast. That was really fast. 98. That's right. Can't do that. Let's go like this. Missing lifetime specifier. Right, so for string, I believe it's like this. This makes it static, right? I think. How's it so fast? It's scarily fast. Like it's like fucking instant. People said the fucking Rust compiler was slow. While passing this struct, explicit type. Found where? Like this? Man, I'm still not used to Rust strings. How do I take a string as a reference, and then store it in a struct still as a reference? It would be a string from some user input. Maybe the last part's not really relevant. Oh wait, no, I guess it doesn't matter because I can just move it, right? Hold on. Okay, I want tokenize to be static. Yeah, so it'll create a tokenizer with source. Tokens equals vec new. I think well that's the same, so I'll just kind of copy that. Sorry, let tokenizer equals this. So I don't need any of these self things. Why is this syntax highlighting breaking here? Because that should not be an equal sign. For some reason. I really hate that, how that's like a difference. It's kind of annoying to remember, but maybe there's a good reason for it. Okay. So I don't use self anymore, I use tokenizer. Which is actually easier to read. I mean, obviously it's longer, but I mean, like, it's more clear. Oops. Okay. Right, so strings. Yeah, but I want it to be string view. Yeah, but I'm just writing it took. Yeah, but in this case, I'm assuming. In this case, the user's string is assumed to stay in memory. In this case, I do want to borrow the user string, as the struct is but temporary. A bit of encapsulation, if anything. What am I returning? I'm returning tokeniser dot tokens. But I hate this, by the way. Like, why do Rust people think this is good? Like, an expression at the end of a thing should only be used when when the function is only an expression. Otherwise, like, you just have it's just so confusing to read. Like, this is just so much easier to read, right? Like, okay, this is the end. Instead, I see this and it's like, why is it just that? It's just weird. Like, maybe I get used to it, but I still haven't gotten used to it. I've been coding and like looking at Rust for a bit. I don't know, man. Lifetimes of the right call. This is actually quite interesting. What if my struct is purely static, like a singleton? To give some context, I have a tokenizer class, tokenizer struct, that only contains the method, the public, that only publicly contains tokenize, which returns a vector of tokens. Yeah, but then I can't have helper functions. Wait, modules exist. Oh, I'm so silly. I forgot that you don't need class-based OOP, because Rust has modules, and I have not been leveraging it at all. See, when you get too used to C++, you think of modules as just like these, just like includes, copy pastes. In Rust, they actually hide implementation details. They're a form of encapsulation, so I should really be using that. So that is totally my bad. Let me do this. I knew something felt wrong. So let me add. Right, so we're gonna add all this stuff now. All of it's gonna be going straight to our main function. What? Straight to our other file. So we just have the main function. That's what I meant to say there. This is our module. I can't remember how you define modules. I'm just gonna look at my previous projects. In fact, let me look at my old tokenizer. It's probably a good idea. Holy lag. Tokenizer. So you got pub. So yeah, so all these are public. Token meta is public as well. Token error would probably have to be public too. Tokeniser is no longer a struct. Yep. So all these variables are actually just bound to the function. So that's fine. Then we don't need the impl, and then this can just be like this. We just pass in the self, and then it'll do it. Yeah. Like add token, and then you would have pass in a token, but you'd also pass in a token list, which you may think is redundant because it is, but Rust doesn't give you a proper way to hide it, unless I'm mistaken. Okay, so how would I, for example, wrap vec dot push token foo 5 sorry, current line to vec to add token foo. Does Rust allow for this kind of? You can't really do that. I thought so. Yeah, so I was right to do that though. Okay. Question is, how much do I actually include here? It really depends on what my helper functions are, right? Yeah. Now you could argue that this is not much nicer than just doing this. I am inclined to agree. But I don't know. Sorry, I need to toilet. I'm gonna go real quick. Be back. Now that ain't quality content. I don't know what it is. Okay. Where was I? Right. So sorry. If I have tokenizer, immutable self. Tokenize inputs add string. Yeah, so it is a static string. I did it correctly. So why is it saying it's incorrect? How do I store source? Fuck hell. Fuck hell. To be fair, source is just source. Like this, I guess. And then just remove it from here. Okay, let me do that. Oh, so this order is out of whack. Just realized. Okay, now it's in whack. And source is only ever used there, right? Yep. Let's try this again. Silence? What? Okay. Tokenizer 950. I don't know what you're talking about. I probably didn't save this. That's why. Going to import mod tokenizer. Yeah, how do I import modules? Oh my days! I'm so out of it for Rust. Yeah, mod tokenizer. That's literally it. Okay, so clear build. Right. Bah. 22 number double. Yep. Okay, it's like an F64. Length is an unknown field. Not surprised. I think it's .len. Sick. So I do need source. Fuck. Okay, so source. Fuck. So source is just a static string. That should be fine. Static string. We'll see. I really don't understand right now. And you don't seem to understand. It's so fast. Holy shit. Expected named lifetime parameter. What do you mean named lifetime parameter? Okay, so I'll do like... What did it say to do? So how do I call it? Tokenizer new. Okay, because it's static, yeah. Right, so A is like a stand-in. Why is that the font? Why is it? Okay. A is a stand-in. I meant like, why is a font like that? And then I just do... That's the lifetime. And it's a string. Okay. I believe I understand. So then I do this. Expected lifetime parameter. Do I have to? Okay. Go to the top. Undeclared lifetime. You can fuck off. Impl... Huh? What? For both? There better be a good reason for that. Huh? Bro, what the okay. Yo. Cargo? Okay. Yeah, so length is not a thing. So it should be, I think it's just not len. Because it's static. Could be wrong. Method not a field. Okay. It's len like that apparently. And likewise, I don't know why it's abbreviated, but whatever. C6 would I mean, like I'd rather just spam recompile than have like a list of all the errors, because like I have to scroll up each time. It's really annoying. Self.current.chart index, and like the fucking line numbers change and everything. Self.current chart index, expected U32, found U size. Yeah, that makes sense. I was thinking actually. change those. Index should be U size as well. That should be everything. Current line number expected U32 if I use fucking where? Here. Yes. Okay. Unknown field self.index. What's index meant to be? This should say current char index. Don't know why there wasn't that already. String indices are ranges of U size. The trait slice index is not implemented for U size. What is the fuck? How do I get an index, a char from a stir? It's like chars.ash or something, like similar to Java. That's right. So source.chars.nth. That's correct. If you're used to C++ and C, or rather just C, you might hate that, but don't hate the king. Hold on, source a vec of chars. That would be smart to do. Uplan source is now chars. I'll call it source. Source is now a source is now a vector of chars. It'll be s.source.chars.collect, and by source I mean input, because I'm going to rename this to input, and we'll call this self.source. Look at that, guy. Chat. And then to get index, I think, yeah, and now I can do normal array index. So I'll do like boom 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 fuck boom 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 bap bap beep bap pow. Perfect. And then this will be a vec of char, and this no longer has to be tied to a particular lifetime, which just makes my life a tiny bit easier. It's actually not that significant, but okay. So this function doesn't have a self parameter. Yeah, so 74. I think the error is here, right? Tokeniser dot source. So char equals get tokeniser dot get current char, which will just return this. So get current char, which is take a self pointer and return, and just return that. Except instead of tokeniser, it'd be called self. Ain't that easy? I could do like that, to be fair, but I'm not going to. Alright. Let's just solve that issue. Get current char, mismatch types, kill me. Oh right, I need a that's right. Nice, it uses type signature. No variant or associated item named comma, found for enum, right? I need to actually define these things. So I guess that's like the crux of the errors. The crux of the errors. Like the comma, what's a comma? A comma is like a separator. Yeah, I'll just add them. Ones like don't fit into any particular group would just be free like that. Asterisk, plus, minus. The thing is, like, they could be used for so many different things, so it doesn't make sense like to group them in like the operators or whatever. Oh, I suppose they are operators, to be fair. That is actually correct. Pub enum operator. We have asterisk. First we have plus though, and minus. Goodbye. So operator. Bang and bang equals, I guess. Okay. So you got operator and operator. See how stupid this is? Like, why can't I just do this, you know? One day, bruh. Maybe there'll be like a miraculous update. Hold on, can I just do this? Huge. Okay, that should fix a few of the errors there. Not found in the scope. Operator. I think OCaml was the only language where I was able to get away with, because like it knows it's a token, so I can just do this, and it knows it's an operator, so it just does this. I think OCaml was the only language so far I've used that allows that, and I don't understand why the others can't. Maybe because like it's a performance thing, but I'd rather have the ergonomics over the performance. Pub enum operator. No semicolon. Tragedy. There is a semicolon. What? Why? What the fuck? Okay, operator. Okay. Ah! Damedane. 129. Mismatch types. Right, that'll be okay. Okay. What in the world? If this is intentional, prefix it with an underscore unused variable on line 78. I'm gonna shoot myself. How was that? Oh, because I did self.index somehow. Got a bunch of borrowing errors now. The bar checker's kicking in. Cannot borrow tokenizer is mutable as it is not declared as mutable. 91. Let mutable tokenizer. Is that literally it? Yep. Enum. Never used. Don't care. Token errors never used. What? Yeah, it is. I mean, it's not used, but like it's returned. Associated items, add token. Just never used. Okay, let me go back to my main function. And token. So what? Tokenizer. Colon. Is that right? Why is it lowercase? Oh, because that's the module. How do I import stuff? Oh my god. Use? It's private. Do I need both of these? So where's the struct? Sorry, though, this should be a public function, shouldn't it? Yeah. This should be a public function outside of the struct. So just like this. Okay. Yep. And it should probably be the top of the thing as well. But at least below all these. So then I'll just use Tokeniser. Don't need that. Okay. So that's like this. Still a lot of unused errors. Oh yeah, I've returned something, isn't it? Let's tokens. And then can I print tokens? Right. So if I use this, no, I need to implement the trait debug. Right, so for token error, token meta, all of them, I need to hashtag derive debug. Do I need to do it for the enums too, or just the struct? You know? Is it outside? Huh. My syntax highlighting for it is different now. It used to be just one color, but that's easier to read. It wanted to do it for that too, so I guess I need to do it for all of these then. Okay. Warning. Okay. Just warnings. I think it works then. So if I try to cargo run, it does run. I get okay, token meta, operator plus. Awesome. Alright guys, our tokenizer is actually functional. You can't see the output because I'm blocking it with my fat ass. Let me just move this here, I guess. There we go. So in our code, I have this, right? I just do the plus, and it does indeed output the plus operator. If I do a plus star bang equals, and cargo run, then we get a plus asterisk bang equals. Awesome. And if I do something invalid, like a cheeky $, how dare you, I get an error. Token meta. Never mind, because it, yeah. Let me add the error first. So to get the errors working, if match errors, so match tokenizer.errors. Actually, I'll just do this. If let error is option, right? If let sum errors equals tokenizer.errors, then return errors. Otherwise, just do okay. There's definitely a better way to do this, but is that even correct, first of all? It is correct. Okay. Sick. You can't see it, sorry. I get an unexpected character here. I don't get the line number because I haven't done that yet, but I will do it at some point. So there you go. $sign for an unexpected character. And for this, is there a cleaner way to do this? Okay, or else. So I'd map it to area. Yeah. I'll just do a match statement, honestly. So match tokeniser.errors. If it's some e error equals error, right? Not equals. This goofy arrow. If it's none, then okay. Tokeniser.tokens. There you go. That's nicer. Okay. Cool. It works. So to get the other stuff, token error now is an enum. Could probably just make it a struct as well. So token error pub struct token error meta maybe. No, it's just token error. This will do token error type. I hate this naming scheme, but I'll fix it later somehow. I will try to figure it out later. So we need a pub error of token error, and then the line number. I don't actually need the line number for here, do I? Yeah, I really don't. Well, no, I do need it. Do I need it? I'm trying to think. I might need it for like later stages of parsing, so I guess I'll leave it in for now. But yeah, token error takes that. So I will push. Yeah, so let's error equal token error with the error as token error unexpected character C, and the line number as self tokeniser dot current line number, and then push error. Okay, that should be more descriptive now. Cycle detected. Line 108. Should be a semicolon. And that should be as, yeah. Pub struct took an error. Pub error took an error. Recursive without indirection. Whoopsie daisy. Type. I might just start prefixing all my enums with E, you know, because like how do I, like this is an error, but this is just the error with more information. Like they're both an error, so like what do I call this? Token error. Like type isn't enough because it does contain information as well, right? So like it's kind of just weird. If anything, it'd be better if, yeah, I don't know. Pub struct token error. Should we type? Ah. Okay. So there you go. You see that I have this, and it says I have an unexpected character this at line 0. If I were to do a new line instead, it'd probably give me an error on the new line. Yep. So let me just go ahead and allow new lines real quick. Oh, this is messy. If it's a new line, then do nothing. Or it's just like this, I think. That's how you do it. That worked, yeah. Also, line number needs to increase. Ah, fuck me. Okay, hold on. Let me just do this real quick. So if it's a empty line, it should only increase the line number. So tokeniser dot current line number plus equals 1. Is there plus plus? Is that a thing? I guess I'll just run it first. If I do plus plus, will it still compile? It will just say no, not valid postfix operator. Okay, so now I have lines. Okay, I have lines. So you can see my error is I took an error at a character here on line number 1. 1 because we're 0 indexed. If I had like this followed by a bang equals and then a new line, then it'll be on line 2. Awesome. And it can also detect, since it's a thing, it can detect an array, a vector. It can detect multiple errors. So if I have 2, you see on line number 0 I have this one, on line number 2 I have this one. Cool. So we're already making great progress. Now, I mean, this isn't too different from my calculator, but anyway, so far so good. So that's that. I'm not even following the fucking guide at this point. Longer like seams. Yeah. So you have peak. Alright, comments have a slash, yeah. So I'm trying to skim through here. How do I do other things? String literals. Yeah, okay. I'm gonna stop there. But I will continue this soon. But yeah, it's quite a lot of code already. But like, I can already see how this. Like, I mean, like so far this is just the same as my calculator thing. The real challenge will be with the parsing stage, because then I need to know how to like create statement trees, which will be interesting. Because like an expression is fine, because like every expression is just a tree, but statements, like, are statements like a vector of ASTs or what? I don't know. So I'll come back to that later. But yeah, so far so good. Can definitely make this look a lot nicer by like wrapping some of this logic, but for now this is fine. So I'm going to commit this. Look, you forgot to be committing anything so far. Get started on tokeniser, and push. All right. So I go back to my If I go to my project. Oh, look, it's a new day. There it is. Tokeniser. So. Yep. Cool. Well, that's that then. I will continue this in another life. I mean, another day. And for now, that's the end of this recording, because it's already like 1 a.m. So yeah, I'll keep following the guide. At this point, I don't know how closely I'm gonna follow the guide, because like I'm also doing it in Java, so I can't just copy paste what he's doing. Not that I should be anyway. So I'll keep reading it for like the concepts, but at this point I'll probably just be skimming through it. Yeah. But anyway, cool. RSLox will be completed soon. If I were to set like a target, I want to finish this project in the next 2 weeks. So like to give some I guess like timeline. My brother arrives in the UK to visit me, and the rest of our family, on the 11th of June. Where today, as of like today, with the midnight turns, is the 1st of June. So I have 11 days. Before he arrives, I want to finish this entire language, if possible, and I want to finish also my NUCC CPP library, or like at least like those steps I outlined. Sorry, that's a different video, but anyway, that's another project I'm working on. This one, I want to finish what I set out to start, to do whatever for this. And so I want to do all that in 11 days. I know that sounds ambitious, but I did realize, looking back at my channel videos, I only started using Linux like a month ago. Like, look at all these videos I made, right? And I look from my Hello from RSLox video. This was on April 28th. Today was, now it's yesterday, but like an hour ago, it was May 31st. So literally like just a bit over a month since I started using Linux. That's like 33 days? Not much time has passed at all, and I've done all this stuff in the meantime. You know, and that's like on top of like having uni coursework to do, which I no longer do. So I think I can achieve quite a lot in 11 days. Anyway, yeah, so subscribe to see more progress on this, and if you watch this video, the 2 hours 50 minutes or skim through whatever, then let me know. Yeah, just let me know any thoughts you have, any questions, any ideas you have for me, any tips and tricks, you know, whatever. I'd be happy to know. Until then.